I'm very, very, very happy to welcome you to Niklas from LabDAO. He will be presenting on LabDAO's recent efforts and work. Who here knows about LabDAO? Anything? Woo! Okay, a few people already do. Okay, well, I think you can assume some pre-knowledge already then. Take it away. This will be more of an advanced session then, I'm assuming. And I will time you and will be available.
Sweet. Can I just click myself through the slides?
You can absolutely do that,
right.
Yes. You can also do, if you want to do this, that's maybe work better.
Sweet. Okay, hey, I'm Niklas with LabDAO, and I am going to give you a bit of an introduction to what is LabDAO, it's decentralized science. I'm not going to dig too much into Benji's talk, so we can, which is actually nice because then we can go a bit into the deep end of where we are. Actually, I talked to Lily from our team this morning. It's like, I really want to talk about this one piece of the mechanism. We don't have any actually graphics for it, but I'm just going to put it on slides and people have to go with me and follow along with some like hand-drawn sketches. So I really want this to be not less of a talk and more of a fireside chat. So that's the intention. So let's get started. So the core idea with LabDAO sort of started lingering in my head, and Ari Lippman and me, we posted this initial Substack that then sort of gave rise to this organization. And my personal story is I like to motivate it with this graph where you can see here the net in and exports of inventors, where an inventor is defined as someone who has authored a patent, and you can see different jurisdictions. And you can see that there's basically 1/2 countries in the world that are net importers of inventors, and then basically the rest of the globe are exporting inventors. And my personal story is I was born here, my parents moved me there, and we had to go back and forth, and eventually, also always because of some visa restriction, I had to go back to Germany right before COVID hit. And I was a computational biologist, and I was working at the Broad Institute. All I knew was my laptop and AWS login credentials, but I still couldn't be with the Broad Institute anymore, which I really loved as a research organization. And I was wondering, well, why? That doesn't make any sense. There should be a way for scientists to collaborate completely online and work from wherever they are. And then you start to dig deeper into, okay, what does an institute actually mean? Why is it difficult to be completely remote? And what are the economics of a research organization? And so the core motivation was, let's build a home for inventors that's completely online. And working from anywhere is not only good for scientists, but it's also actually good for business. And there are some statistics here. This is a graph that shows you the percentage of between-city collaborations among all the patents that are filed in the United States over time. And you can actually see that more and more patents that are being filed are coming from cross-city collaboration. So teams that invent, they tend to be more and more distributed. And this is obviously has something to do with the technological progress that we have around collaborating widely using digital means. What I think is actually even more interesting is that these remote teams are more disruptive. So this is another study, and I didn't fit the citation here, but basically what they did is that they went into the patents and they then did a bag of words analysis and looked, okay, of the patents from the remote teams, is the combination of words, is the combination of concepts more novel relative to the whole bulk sample of patents, or less, and they actually show that while in the 80s, when communication technology was not that sophisticated, distributed teams would actually lead to relatively less disruptive patents, less extraordinary patents in terms of the word combinations that are mentioned. Actually, since the 2010s, these teams tend to actually be more disruptive. They tend to come up with more creative concepts. And the overall explanation that the author provides, and I personally adhere to, is the idea that if you have a group of people that live in different cities, every city has access to a different pool of tacit knowledge about a technology. When you're in Berlin, you have a lot of tacit knowledge about crypto and techno music, and when you're in San Francisco, you have a lot of tacit knowledge about AI safety and effective altruism, perhaps. And when you then have a team that works across, concepts start to merge very quickly. So not only is it potentially good for the individual scientists to be able to work from wherever they are, it might actually be good for the whole world and whatever that team wants to do commercially, if they're able to collaborate extremely broadly. So at LabDAO, we're building and using tools to make it easier for scientists to work together completely online. And we're part of a larger movement that's called decentralized science, and there's a ton of projects in this landscape. This is by Jocelyn, who's also co-founder of LabDAO, and yeah, actually some people in this audience can find themselves on this map, it's has been awesome to see all of this basically explode over the last 12 months. So I'm going to rush through this. Decentralized science. Okay, well, science is basically a knowledge creation process, and I guess scientists would say it's a formal knowledge creation process, a formal thinking process. And when we have new technology to communicate, so new information technology, historically it often leads to new forms in which knowledge is created. You can think about the printing press, and books can be printed at scale. Now the way that information is exchanged is also a different one. It's become actually gradually decentralized. So pre-Reformation, you had monasteries that would copy books. Now post-Reformation, enabled by the printing press, the ability to transfer information was becoming more distributed and more accessible. And the web, like Web 1, Web 2 enabled the open science movement, so people started to ask, well, why should I have a subscription if I can just post the thing online, and why should people have to pay $40 to have access to the print when they could just download it online? And now with Web 3, we have distributed storage and tokens. People start to ask, well, why can't I own the outcome of my work? Why can't I fund the scientists directly? And why can't the scientists just go directly and seek funding? And those are sort of the core ideas of the decentralized science movement, the way that I see it. And really the technical primitives on which all of this is based is content addressing. So you can put everything on IPFS, everything is citable now. You don't need to wait for a DOI to index your object, everything is citable. Even a blog post, a Twitter space, everything. Distributed compute, so reproducibility is no longer opt-in. If you use some of these tools that are built on top of Web3, you can run your container workflow, for example, in a way that is very, very reproducible, and if paired with the right technologies, perhaps even has an on-chain trace, so you can go back and see what happened. We have tokens, so instead of co-ownership, we can have instead of co-authorship, we can have co-ownership. And we have DAOs that basically result as a consequence of these tokens, where a DAO is a decentralized autonomous organization and actually lets the owners of these tokens then collaborate and define certain directions of the organization. And obviously, the sort of high-level ideal of it all is that we want to give everyone the ability to raise funds for a scientific project. We want to give everybody access to laboratory researchers to do the thing, and then be able to share data in new economic ways that are both making available to the rest of humanity while also respecting the value that was created by the individual scientists or the team of scientists. I'm going to skip a bit ahead because I really want to actually get into a bit.
3-minute warning.
3-minute warning. Gee.
If no questions come, you can dig in deeper.
Okay, well then let's really. I'm going to throw you into the deep end. So
I think we handle it.
at LabDAO,
Take the flippers off, guys.
So the way that we think about it, what we really care about LabDAO is providing tools for science. Because if you think about, if the task was create a research institute that's completely online, okay, well, there's lab space, there's office space, and there are basically scientists that are running around. And so the lab space, we need to abstract that. We need to give them a way to access scientific tooling, and that's both scientific compute, but also access to actually physical laboratory services. If you think about the office space, we need to give them a place to gather, and that's what we're doing with the community and creating spaces for the community to come around. And then projects, you actually need to do some science, and you need to be able to trace who contributed to the project, where do you send the science funding that was raised, and you need to build some mechanisms for that. The way that we think about this at LabDAO is that we have individual projects, so the project as the atomic unit of science, and that every project itself is basically an absolute micro DAO. So if you initiate a project, you mint a supply of certificates that represent governance rights in that project. And just like a startup founder, when you found a company, and initially you own basically 100% of the equity, 100% of these certificates. But then as you go about your project, you give away those certificates freely to everybody that has helped, that has contributed to it. And because these certificates are just certificates, they're not necessarily pieces of stock, because in science you don't really know whether something will turn into a company or something else. We believe that there's this one unified concept that can be used to track contributions for whatever scientific project you're doing, irrespective of whether you might be that 1% outlier that turns into a company, or the work that you've done has mostly scientific or cultural value. And maybe at this point, I am going to take a step here, and this is where we get a bit into the rougher parts. But I really, I couldn't hardly imagine a more awesome audience to bounce these ideas off. So I really want to take advantage of this. So this is basically now the blueprint, a blueprint design for the mechanism the way that we currently see it. So can we create software? Can we create mechanisms for scientific organizations to form and then reproduce? And we believe that LabDAO can be sort of the proto-cell. You have a collective of scientists, and they form a research organization, and the organization is defined by token ownership. So in this case, these would be all the lab token holders. And they come together, and within that sort of hot plasma, a project is initiated. So someone reads a paper, another member has some tacit knowledge about a technique. They say, why don't we combine this? Let's form a project. Now, what is that project? On chain, a project is a multisig. It's just a multisig, like a wallet basically, that says we want to do this, send money here if you want to support us. And then what they do as well, not only do they create the multisig, they also issue tokens and say, we are minting 100,000 impact certificates. These certificates literally just give you governance rights over whatever this is we're doing right now. In the beginning, it's just the idea, but over time, obviously, those certificates, for example, give you access to the research data that the scientists have been collecting. And if they eventually went on to issue any type of patent, then obviously having that access to that certificate would give you, for example, ability to license it or participate in any royalty stream that might result from that. And this would also be the stage where there could be basically a legal block-like integration with IP NFT concepts, where then this collective with this governance tokens could actually emit something like an IP NFT. Okay, so in the first stage, this all comes together, and we call that the initiation stage. And then after that, however, there needs to be some tough questions need to be asked, because the resources that we have for laboratory service, they're pretty scarce, right? Like you only have so much laboratory space, you only have so much budget to help support scientists, you only have so much compute resources. So there needs to be a curation stage where people in the DAO vote on, all right, should this project have more access to resources versus the other? So they need to be ranked. And the way that we currently think about that is people basically, the curators, stake their lab tokens into the projects, and then proportional to how much they have stake, and this is written here, the curation leads to the individual project to have access to the exchange. So if I receive a lot of votes by the community, I have priority access to all these resources, and in return, the individual curator that staked the lab token, they basically get what you in VC terms would call a ROFR, right of first refusal. They get to basically be, they basically get to participate in the initial token launch of that entity. If there ever was a token launch, it's like there's some risk here, but that's the fun thing about science. You basically try to you try to curate what projects could lead to an interesting outcome, and then you are somewhat self-motivated because you want to vote on the stuff where you eventually want to be able to purchase a governance tokens for. I'm going to wrap up.
Yeah.
So then when that project is done, eventually it graduates and the token becomes liquid. The members vote on that token become liquid, and then everybody else in the whole universe can go and participate, can go and purchase some of those impact certificates as well. And then the whole idea is that the sort of reproductive machinery that you saw here, which is at the core an exchange for services, a mechanism for this curation, and then obviously a higher level meta-governance system for the parameters of the mechanism, that is basically a reproductive set of contracts that can be passed into these projects as they leave. So the replicative machinery that gave rise to new projects that can actually live on in the new project and can lead to yet another research organization that, for example, if it's very successful, might give offspring to new scientific projects. And that way, I hope, in the future, we can have this like whole ecology of research organizations that potentially adhere to like a similar replicative machinery, or even like mutate that replicative machinery and like improve it further.
Wonderful.
Okay.
Lovely. Thank you, Niklas. Man, you've done so much.
Yeah.
Crazy.
Yeah.
Okay, questions, comments. Okay, yes, we'll just go around.
Okay, so this is really cool, and it's more like getting funding to do some research or some project and then see where it will go. And the question is, do you have a vetting mechanism for the proposals? So, for example, as an outsider, I might not know the technical details, but still I want to participate and get certificates, but I don't want to be supporting some research that could harm humanity or others and so on. So how can I get this vetting while I'm not an expert, for example?
Yeah, eventually so either you have an eye for projects that could be dangerous and then you don't stake tokens into them because you don't want to get them access to the sort of resources that are needed to do science. Or you could trust someone to stake the tokens for them.
Okay, so it's not enforced by the system itself to reject, for example, proposals that maybe they are not good or something like that.
Yeah, what I can say is that in the beginning we probably will take a relatively centralized approach and we will not let everything just list straight away, just like with Gitcoin. In Gitcoin, they don't list every project. They check whether it has some minimum criteria. We'll probably have to do the same, and then over time hand it over to like a distributed system of like permission givers. But in the beginning, it's just you want to control the chaos. So we'll have some editorial control. I'm pretty sure.
Yeah, I have a few questions on like what fields are you targeting? Because is the goal just to raise funding, or do you plan to? At some point, I was thinking you were planning to pool resources together. Like you were talking about compute resources, but I was thinking, how do you do that with wet labs?
Yeah.
How do you move people across the world? And slightly connected question, saying like, how about fields that don't really have any economic perspective? Like, how do you fund humanities, for example?
Mm-hmm, mm-hmm. So, first question: what is the type of science we'd love to fund? The science. So this is just a snapshot of some of the projects. So we have a project collaboration with a rainforest integrity focused project. So that's satellite image analytics, everything where you can use computation. So the mix that I tend to tell the team is like, I think we should focus on 80% computation, 20% physical. Because the 20% physical, that's where a bit of the magic comes in. While there's internet online communities like doing something physical, but we can still be most effective when we're computational. And then in terms of the labs, we've partnered with organizations to have about 3,000 laboratory services at our disposal. So we can like basically broker these CRO contracts for the labs. The truth is nobody's using them right now because there's not enough money in the system. Like the scientific projects that haven't raised enough funding to actually be meaningful users of these services. That's why we're focusing also on the compute. Like initially, the idea was let's focus on the physical labs, but right now the field is just not well capitalized enough to actually make use of these resources. Now, second thought. Not only what type of projects, but also what about other fields? What about fields that they don't have a potential commercial angle? And this is where I think these impact certificates can be really helpful, because with an impact certificate, especially we want to use a dialect, like a modification of them. it's basically an NFT, and the idea is that humanities might not, when you buy a certificate for a humanities project, you can be pretty sure that that's not going to be a royalty share in some kind of patent, but you can still use that as basically convert your financial capital to social capital or cultural capital. For example, that NFT could give you access to the latest writing of the author, or that NFT could come with some beautiful artwork that was generated on top of some of the output, and you can demonstrate that to others. So the same very selfish drivers that make people put their names on libraries and like buildings at university campuses, that same sort of driver, I believe, can also motivate people to say, okay, I have this like one author, scientist that I want to really support, and I want to be the philanthropist, and then I have tokens to show to everyone that I supported that. And the scientists can then basically tie every kind of like goodie or like special access to that and say, people that hold my tokens, like I do like an AMA, or there's this sort of
the only fans of
playground that I see there.
Who has access to these certificates?
Yeah.
So who can participate?
So the way that I think about it right now is that in the first stage, the initiation, curation, everything before the graduation, the certificate is illiquid, can't be traded, can only be earned. So you need to be either the curator that basically called dips. I want to participate in that token sale, but I'm putting money at risk. I'm purchasing a lab token, and I like add value to the overall ecosystem. Or you are actually a scientist and you're working with that author, and you actually become part of that contributor graph. Once that project is sort of in the graduation phase, the token becomes liquid. You list it on OpenSea or even some form of Uniswap, and then people can buy into it and enjoy some form of exposure to it. So you delay the market mechanism to some time. And I think that's what academia or science is all about. It's like you create a bit of like a useful friction for market mechanisms, so that creation and speculation, speculative science can happen. But then eventually you need to expose yourself to the market.
And another one. Well, those were great questions. Starting right with the risk radar. That's a tough one. Thank you, Niklas. This sounds incredibly exciting. I remember the first time, when you guys were just like launching, and it's insane how much you've done in such a short time, and like how much you've thought out about it. And like I just saw Leon Peschkin walk through, and he was like, "I want to do this for bio." So you guys should definitely talk. So I think you probably have a lot of potential customers in here, and hoping that you make yourself available for some of them later during the discussion.
Yeah,
thank you very much. That was wonderful.